Greetings, ladies and gentlemen. In this video, we are going to continue solving this past paper, which is the Science Paper 1, 2020. So the last time we had this paper, we ended on question B8. So today we are resuming this paper from question B9. Question B9 reads, phosphorus stage 2 can decay by emitting beta particles. Question BA, what is a beta particle? What is a beta particle? So the question is carrying 1 mark. We are going to say a beta particle is a high energy and fast moving electron. A beta particle is a high energy and fast moving electron. Okay, so without wasting time, let us just say a beta particle is a high energy and fast moving electron. We are done with question A. Let us move to question B. Question B. If the proton number of phosphorus stage 2 is 15, Roman numeral 1, state the new values of proton and mass numbers of nuclide just after it emits a beta particle. So they want us to state the new proton number and the new mass number. So the first thing that we are going to do to state the new proton number and the mass number is to come up with the beta radioactive equation. Okay, so to determine the proton number and the neutron number after beta decay, we follow these simple rules. So rule number 1, beta minus, okay, or the negative beta decay. So for negative beta decay, a neutron turns into a proton. So proton number increases by 1. Neutron number decreases by 1. Okay. So in case of a negative beta decay, a neutron in the nucleus is converted into a proton. So therefore, the number of protons in the nucleus increase by 1. Then the number of neutron in the nucleus decreases by 1. So this is one of the rules that we need to consider. So therefore, we are going to apply this formula, which is here. X as an element, Z is representing the mass number, A is representing Z is representing the proton number, A is representing the mass number. Okay, then here we have the proton number plus 1. So which shows that there is an increase in the number of protons. Then the mass number has been maintained. The mass number has been maintained. So therefore, we are going to say X is representing the element, Z proton number, A mass number. Then we are going to have an element. We are going to have an element with an addition of 1 proton to its nucleus, then plus a beta particle, plus beta particle. So where there is X, we are going to write P. So the proton number of P, or the proton number of phosphorus, is 15. The mass number is stage 2. So remember, the number of protons will increase by 1. Then the number of neutron will reduce by 1. Reduce by 1. The mass number will be maintained. So nothing will change. Nothing will change. So therefore, our our radioactive decay equation will look like this. P representing an element, 15 atomic number or proton number, H2 representing mass number, 16 representing new proton number, H2 representing new proton number, plus the beta particle. So therefore, to answer this question, to state the new proton number, we are going to say the new proton number is 16, according to what we are given here. The new proton number is 16. Then the new mass number is H2. So nothing has changed to mass number. So the mass number has been maintained throughout, as indicated by the radioactive equation given here. Okay, we are done with this question. Let us move to the next question. We move to the next question, which is question B, Roman numeral 2. Write the decay equation for pH2 after emitting 2 beta particles. Write the decay equation. So here, we are not going to waste time. We have already constructed the decay equation. So this is the equation we are simply talking about. Okay, we have pH2 as its mass number, 15 as its proton number, and we have the daughter pH2 as its mass number, and the 16 as its new proton number. So this is the decay equation. We are also done with this question. Let us move to the last part of question 9. The last part of question 9, which is question C, phosphorus stage 2 can be used to prove that plants absorb phosphorus nutrient from the soil around them. State 1 safety precaution which should be taken into consideration when doing experiments with the phosphorus stage 2. The question is carrying 1 mark, so therefore we need to provide the information that is equivalent to 1 mark. Okay, so they want us to give the safety precautions, the precautions that we need to consider when handling phosphorus. Okay, so number 1, shielding. Use grass. Okay, use glass or plastic shields instead of lead, as beta particles can produce harmful X-rays when interacting with lead. Wear protective gear. So wear protective gears like gloves, lab coats, safety goggles to prevent contamination and exposure. Okay, to prevent contamination and exposure. Precaution number 3, minimize exposure. Use tongs or remote handling tools, or work quickly and keep a safety distance to reduce radiation exposure. Okay, so these are some of the precautions that we need to consider when handling phosphorus. Okay, so therefore we are going to say wear gloves, lab coats, and the safety goggles to prevent contamination and exposure. Okay, we are done with this question. Let us move to the next section. We move to the next section, which is section C. Here, we are expected to answer 2 questions. Since we are revising this paper, we are going to answer all 3 questions. Question C1, figure C1.1 below is a velocity time graph. Velocity time graph representing the motion of a motorcycle traveling along a straight road. Okay. The question continues. Describe the motion of the motorcycle between the points Roman numeral 1, O and P. So they want us to describe the motion between O and P. So the motion between O and P, the motion between O and P is, okay, so before we describe these motions, let us look at this graph. We look at this graph. So this one is representing uniform acceleration. This one is representing uniform acceleration. So the slope is representing uniform acceleration or constant acceleration. Then the flat line on the speed time graph is representing constant speed. The flat line on the speed time graph is representing constant speed. Okay. Then this one here is representing the acceleration or retardation. This one is representing the acceleration or retardation. This one also is representing constant acceleration. Okay, so this is constant acceleration. Now let us come back to our question. We come back to our question. So they want us to describe the motion between O and P. So the motion between O and P is uniform or constant acceleration. Uniform or constant acceleration. We come to P and Q. P and Q. So they also want us to describe P and Q. So P and Q is representing constant speed or constant velocity, uniform velocity or constant speed. We come to Q and R, Q and R, Q and R. So Q and R, these are representing constant or uniform deacceleration, constant or uniform deacceleration. So we are done with this question. Let us move to the next question, which is question B. Question B, what is the maximum speed of the motorcycle? What is the maximum speed of the motorcycle? So without wasting time, the maximum speed of this motorcycle is 40 meters per second. The maximum speed is 40 meters per second. We move to the next question, which is question C. How long did it take the motorcycle to retardate to rest? The question is carrying 1 mark. Okay, so the car started retardating from C. So let us find the corresponding time. So to find the corresponding time, we'll come downward like this. Okay, come downward like this. So here we have 10, here we have 8, here we have 6. So it is obvious that the number between 6 and 8 is 7. So the car started retardating when the time was 7 seconds. So from so it took 5 minutes to retardate. So from 7 seconds to 12 seconds, there is 5 seconds. Okay, there is 5 seconds. So therefore, we are going to say the time here is 5 seconds. We are done with question C. Let us move to question D. Question D, calculate the total distance traveled by the motorcycle. Calculate the total distance traveled by the motorcycle. So to answer this question, we need to remember that area is equal to distance under speed time graph. So once we find the area of the shapes on the speed time graph, then that area is equivalent to the distance. Okay, so area under speed time graph is equal to distance. Area under speed time graph is equal to distance. So to answer this question, we are going to label these shapes. So the first shape that we have is triangle. The second shape is rectangle. The third shape is triangle. Let us find the area of the first triangle. So the area of the first triangle is uh, we are going to say distance is equal to 1 over 2 times base times height. Okay, times base times height. So 3 seconds 3 seconds is acting or is representing base, is acting as our base. 3 seconds is acting as our base. So where there is b, we are going to write uh, 3 seconds. Then height from 0 to 40. So we can see that the height which is here is 40 meters per second. So 40 meters per second is representing the height. So this is our height. Okay. Then the distance therefore is equal to 1 times 30 times 40. We are going to get 120 divided by 2. 120 divided by 2 is equal to 60. So guys, as we can see, we have successfully managed to find the distance covered by this shape. Now let us also find the distance covered by this shape. So to find the distance covered by this shape, we are also going to find the area of the rectangle. The area of the rectangle, okay, the area of the rectangle is equal to length times breadth. Okay, length is 40. So the one that is representing length here is 40 meters per second. And breadth, the distance between the distance between this point, the distance between this point, the distance between this point and this point uh is 4. I mean the time between this point and this point is 4 seconds. So we have seen that 4 seconds is the one that is representing the breadth. Now let us say 40 times 4. 40 times 4, we are going to get uh no, this one should be this one should be this one should be 4 seconds. 4 seconds. Okay, this one should be 4 seconds. We are done with this question. Let us move to the next question. Let us move to the next shape, sorry. Let us also find the area of this triangle. So to find the area of this triangle, we are going to say distance is equal to 1 over 2 times base times 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 height, which is 40. Then 1 times 5 times 40, we are going to get 200. 200 divided by 2, we are going to get 100. We are going to get 100. Okay. So ladies and gentlemen, there was a mistake here. Here we're supposed to have 160, not 200. So if we say 40 times 4, we are going to get 160. Then we are going to say 160 plus 60. We are going to get 220. 220 plus 100. We are going to have 320. So our answer here is 320. So here we're supposed to have 160, not 200. So here we are not supposed to have 5. Here we're supposed to have 4. So our answer is 200, 320. Our answer is 320. We are done with this question. Let us move to question E. Question E, calculate the average velocity for the whole motion. calculate the average velocity for the whole motion. So we are going to say average velocity is equal to distance divided by time divided by total. Average velocity or average speed is equal to total distance divided by total time. Okay, so the total distance we are from finding a total distance which is 320, and the the total time is 12 seconds. The total time is 12 seconds. So here we're supposed to have 12 seconds, not 5 seconds. So the total time is 12 seconds. So we are going to say, let me use my calculator. We are going to say 320 divided by 12. We are going to get 26.66 meters per seconds. So here, let me do this. Let me make a correction here. So I'm going to say average speed is equal to 320 divided by total time, which is 12. Okay, divide by total time. Divide by total time, which is 12. So average velocity, therefore, is equal to 26 meters per seconds. So our answer here is 26. We are done with this question. Let us move to the next question. We move to the next question, which is question A, which is question C2. Question C2: Elena carried out a Hooke's law experiment. Obtained. Elena carried out a Hooke's law experiment and obtained the following results. Okay, so the first row we have mass in kg. The second row we have length of loaded spring in centimeters. The third row we have applied force in newtons. The fourth row we have extension in millimeters. The first question: copy and complete table C2.1 by finding values of applied force in Newton and extension in millimeters produced. The question is carrying 2 marks. So they want us to complete the table by finding values of applied force in newtons and extension in millimeters. So to answer this question, the formula for finding the extension of a material such as a spring or wire is extension is equal to length minus the original length. Okay, extension is equal to length minus the original length. So E stands for extension, then L stands for stretch length in meters or in centimeters. Then LO stands for original or unstretched length. Then weight is equal to mass times acceleration. Weight is equal to mass times acceleration. So therefore, to find the first applied force, we are going to say the first applied force, the acceleration we are talking about here is gravitational acceleration. So we are going to say mass, which is 0, times gravitational acceleration. We are going to get 0. Then we come to the next column. Mass, which is 0.02, times gravitational acceleration. We are going to times a gravitational acceleration, which is 10 meters per second squared. We let us find the extension in advance. So we find the extension in advance. So if we say 11 minus 11, we are going to get 0. We come to this one. 0.02 times 10, we are going to get 0.2. 12.1 minus 11, we are going to get 1.1. 0.04 times 10, we are going to get 0.4 newtons. 13.2 minus 11, we are going to get 2.2. 0.6 times 10, 0.6 times 10, we are going to get 0.6. 14.3 minus 11, we are going to get 3.3. 0.8 times 10, which is our acceleration due to gravity, we are going to get 0.8. 15.4 minus 11, we are going to get 4.4. 0.10 times 10, we are going to get 1. 16.5 minus 11, we are going to get 5.5. So, ladies and gentlemen, as we can see, we have successfully managed to copy and complete the table given here. Let us move to the next question, which is question B. Question B, plot a graph of applied force in Newton against the extension in millimeters. So the question is carrying 4 marks. The question is carrying 4 marks. So we have a graph here. Here we have applied forces. Here we have applied forces, applied force. Here we have extension. Here we have extension. So the first coordinate is 0, 0. 0, 0. The second coordinate is the second coordinate is 1.1, 1.1, 0.2. So 1, 1 point 1, 1.1, 0.2 is here. So we have plotted here. The next coordinate is 2.2, 0.4. 2.2, 0.4. So 2.2, 0.4 is here. The next coordinate is 3.3, 0.6. 3.3, 0.6. 3.3, 0.6 is here. Okay. The next coordinate is 4.4, 0.8. 4.4, 0.8. 4.4, 0.8 is here. 4.4, 0.8 is here. The next coordinate is 5.5, 1. 5.5, 1. So 5.5, 1 is here. Okay. So ladies and gentlemen, as we can see, we are done plotting. We are done with this question, which is question B. Okay. So upon doing this, then we can attract the 4 marks. The 4 marks we saw at the end of the question. Let us move to the next question. We move to the next question, which is question C. Question C, from the graph, determine the spring constant. The question is carrying 2 marks. From the graph, determine the spring constant. The question is carrying 2 marks. So to determine the spring constant, let me read the question once more. From the graph, determine the spring constant. From the graph, determine the spring constant. So before the elastic limit, the graph is a straight line, meaning the material obeys the Hooke's law. The extension is proportional to force. So Hooke's law states that the extension is direct proportional to force, or the applied force is direct to extension. Okay, so at the elastic limit, the material begins to deform. permanently, it no longer returns to its original shape when the force is removed. So beyond the elastic limit, the graph curves or bend, showing plastic deformation, where extension increases significantly with the little added effort, with little added force. Okay, so they want us to find the extension. So what are we going to do to find the extension? So to find extension, we are going to use the formula that we use when we are calculating gradient. So to find gradient, we normally say gradient is equal to y2 minus y1 divided by x2 minus x1. Okay, so let us see, choose two. So we can choose two coordinates from these coordinates that we have. So I have chosen this one and this one. Okay, so this one is 0.8 comma 4.4. Then this one is this one is a this one is a 1.1 comma 0.2. 1.1 comma 0.2. Okay, okay. So here I just want to make a clarification here. So when we are coming up with a graph, we should start with the x. So we have seen that extension is representing x. Then applied force is representing y. So let me write these coordinates properly. So the first coordinate is 1 point. The first coordinate is okay. The first coordinate is there was a mistake here. The first coordinate is 1 point 1.1 comma 1.1 comma 0.2. Okay, 1.1 comma 0.2. Then our second coordinate is 4.4 comma 4.4 comma 0.8. 4.4 comma 0.8. We are going to label this one. This is our x1. This is our y1, our x2, our y2. So this is our y2. This is our y2. So we are going to say this is our y2. Okay. Then let us forget about this one. I made a mistake. I started with the x. I started with y instead of starting with the x. Okay. So we are going to say gradient is equal to y2 we have 0.8 minus y1 we have 0.2 divide by x2 we have 4.4 minus x1 we have 1.1. Gradient is equal to 0.8 minus 0.2. We are going to get 0.6. We are going to get 0.6 divided by 4.4 minus 1.1. We are going to get 3.3. You're going to get 3.3. M therefore is equal to 0.6 divided by 3.3. We are going to get 0.18. So 0.18 is our constant or our gradient. 0.8 is our constant or our gradient. We are done with this question. Now let us move to question D. Roman numeral 1. Did the spring reach its elastic limit? Okay, so we gave this explanation here. We said at the elastic limit, the material begins to deform permanently. So before the elastic limit, the graph is straight. The moment the graph starts bending, so at the point where the graph is starting bending, that is where the elastic limit is. And we have seen that the graph that we have plotted is straight throughout. The graph is straight. So therefore, we are going to say this one did not reach the elastic limit because our graph is straight throughout. The spring did not reach the elastic limit. Roman numeral 2 give the explanation because the graph is straight throughout. Because the graph is straight throughout. We are done with this question. Let us move to the next question. We move to the next question, which is question C3. Question C3, figure C3.1 is a chart showing some components of electromagnetic spectrum. Question A, Roman numeral 1. Use the list below to copy and complete the electromagnetic spectrum chart. Radioactive waves, X-rays, ultraviolet, gamma rays, infrared, and red light. The question is carrying 2 marks. Okay, the question is carrying 2 marks. So they want us to complete the table. Okay, so to complete the table, this is the arrangement here. This is the arrangement. So we'll start with radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays. Okay, so we have seen that here we have microwaves. So therefore, it is obvious that radio wave is here. So therefore, here we are going to have radio wave, here microwaves, then here we are going to have infrared, here we have visible lights, then here ultraviolet, here X-rays, here gamma rays. So we are going to say radio wave, infrared, visible lights here, then here ultraviolet, here X-rays, here gamma rays. So we are done completing this table. Okay, let us move to the next question. We move to the next question, which is question A, Roman numeral 2. State 2 properties common to all members of the electromagnetic spectrum. The question is carrying 2 marks. Okay, so electromagnetic waves travel at the speed of light. Electromagnetic waves travel at the speed of light. So they do not need a medium for them to travel. They can travel through space or they can travel through vacuum. And they are transverse waves in nature. Okay, so the electromagnetic waves are transverse waves in nature with the perpendicular electric and magnetic fields. Okay, so therefore, to answer this question, we are going to say electromagnetic waves travel at the speed of light. Electromagnetic waves travel at the speed of light. We are done with this question. Okay, we can also. Oh, the question is carrying. The question is saying two properties. We are also going to say electromagnetic waves are also transverse waves in nature. Okay, we are done with this question. Let us move to the next question, which is question B. Question B, name a component of the spectrum that Roman numeral 1 has the longest wavelength. So, the component of the spectrum that has the longest wavelength is radio wave, as indicated here. So we can see that radio wave has the longest wavelength as compared to gamma ray. So gamma ray has the shortest wavelength. Radio wave has the longest wavelength. So our answer here is radio wave. We move to the next question. Name a component of the spectrum that is emitted by hot objects, hot bodies, so to say, hot bodies. So, hot objects emits the infrared radiation. Hot objects emits infrared radiation, while very hot objects emits visible lights. Extremely hot objects like stars can emit ultraviolet UV, X-rays, and gamma rays. The hotter the object, the shorter the wavelength of the radiation it emits. So therefore, here we are going to say infrared. We are going to say infrared. We move to the next question, which is question C. Microwaves have a frequency of 10 to the power 10 Hz and velocity of 3 times 10 to the power 8 meters per second. Question C, Roman numeral 1. Calculate the wavelength of the microwaves. Calculate the wavelength of microwaves. So to answer this question, we are going to say, wavelength is equal to speed of light divided by time is equal to speed of light divided by time. The speed of light has been given, which is 3 times 10 to the power 8. So this is 10 to the power 8, not 108. 10 to the power 8. Divide by 10 to the power 10. We are going to get 0.03 Hz. 0.03 Hz. This is our answer. We are done with this question. Let us move to the next question. We move to the next question, which is question C, Roman numeral 2. Stage 2 practical uses of microwaves. Stage 2 practical uses of microwaves. So number 1, cooking. So microwaves are used in micro ovens to heat food. Number 2, communication. Microwaves are used in communication. Microwaves are used in satellite. They are also used in mobile and Wi-Fi signals. So these are two practical use of microwaves. By the way, these are some of the practical use of microwaves. Ladies and gentlemen, this brings us to the end of this video. So peradventure there is a question, you are free to ask.